In this video, we're going to talk about operating the Agilent 1260 Infinity high-performance liquid chromatography instrument. The instrument has 5 key components. The first key component is the elutant reservoirs. This particular model can draw from 4 such reserves, though only 2 are commonly drawn from at a time in order to create your mobile phase. The second component is the pumps, which are housed inside the instrument, and these are used to control the flow rate and mobile phase composition that's going through your column. The third component is the injection port, which has 2 modes, load and inject. While in the load position, your sample can be injected and will flow into the sample loop, which has a set volume of 20 microliters for this instrument. Any extra sample injected will be expelled into a nearby waste container. When switched to the inject position, mobile phase will be allowed to flow through the sample loop and will carry your sample to the column. The column is the 4th component and the most important of the device, as this is where the chemistry that drives your separation occurs. As such, it is important to consider what compounds you introduce to the column, as some compounds can become irreversibly absorbed or adsorbed, permanently changing the chemistry of the column. The last component is the detector, which is housed inside the instrument. This instrument uses UV absorbance detection, which is the most common form of detection used in liquid chromatography. This is what produces the signal information, which is sent to the computer and read out as a chromatogram by the instrument's software. From the detector, the liquid heads to the waste vial, though it should be noted that a fraction collector can be used to recover your separated samples for further analysis. It's important to have proper and consistent injection technique in order to reduce variation in between runs. First, you should make a small amount of the mobile phase you'll be running. This solution will be used to rinse the syringe and sample loop about 3 times each to remove any substances adsorbed to their walls, which could affect your separation. If there's enough sample, the syringe should be rinsed about 3 times with it before drawing the sample to be injected. When drawing the sample, make sure that there are no air bubbles and that you draw a volume larger than the sample loop. This will ensure a consistent injection volume, improving reproducibility. When you inject the sample, make sure the syringe goes all the way in and depress the syringe slowly. Without removing the syringe, switch the position of the injector to inject and ensure that the run has started before removing it and switching the injector position back to load. In order to open the HPLC software, double-click on the 1260 HPLC online icon. So the first thing you're going to want to do when you open up your software is to turn on your UV vis detector such that it can warm up before you actually use it. You're going to want to give it probably about 15 minutes from when you turn it on to when you run your first sample. In addition, when you're ready to run your sample, you're going to go ahead and press this green circle here to turn on your pumps to get your mobile phase flowing. Now, to set up your method, you're going to go ahead and go to this Method tab and choose Edit Entire Method. You only need instrument/acquisition checked, and go ahead and press OK. You're going to go ahead and press OK and go through this window. And in this window, you're able to change all of your parameters. You can change your flow rate, which you probably won't want to change. You can change your mobile phase composition. You can change which files you're actually drawing from. And you can change the time limit on your chromatogram. In addition to this, if you go over to the tab VWD, you can change the wavelength that you're detecting at. In order to perform a gradient analysis on your sample, go to the timetable over here on the right and click Add. This will add a new row to the timetable in which it will reach the specified conditions at a set time. It's important to allow your column to re-equilibrate with the mobile phase in between runs by giving it about 2 to 3 minutes of just pumping mobile phase. This is especially important in gradient elution, and more time should be allowed for this process. A good judge of the equilibration can be obtained by watching for a stable baseline absorbance that lasts for a few minutes. Once your run has completed, you can go to the Data Analysis tab by selecting on this option in the bottom left of the screen. From here, it should open up your chromatogram, and it'll actually show you the baseline that the computer is using to integrate your peaks to give you your areas. The computer is not always the greatest at doing this, and it's especially noticeable when you're doing gradient analysis, and you may have to manually integrate your baseline. In order to manually integrate your baseline, go ahead and click this button up here that says Manual Integration. And in order to choose, you choose the starting point for your baseline and drag it all the way to where the end point will be. And as you can see, it then integrates and actually displays the area here. However, the area was already in the table down here. Other than that, you may have to get rid of certain peaks because they're not actual peaks from your chromatogram. And in order to do this, you come here and choose the Remove Integrated Peaks feature and select the peak that you want to get rid of. The simplest way to extract your data is then simply to print out your chromatograms, as it will have all the information displayed here, which includes your peak area, your peak heights, and the full width half max of each of your peaks.